The next step in the solid design principles is the L within the acronym, which stands for the Liskov substitution principle. Now, this one tends to sound a little bit more complicated than it is. So let's take an example here following along these same lines as we've been working with so far. So I've only just kind of changed a little bit the way that the application is structured. I put all of the validation logic into a validation folder just to get it out of the way. So our application has begun to take on a little bit of shape. It's begun to grow a little bit, and we've been requested that if someone comes to us through customer service or walks up to the help desk or whatever that might be and says, you know what, something is incorrect on my invoice, can you please modify it? Can you set the subtotal was wrong, or maybe the tax rate was wrong, or something along those lines, and to be able to do those types of operations. So being a good little solid design principle minion that you are now, you've said, you know what, I don't want to have that initial or that additional logic added to my invoice class. I want to be able to modify it outside of that. So I want to be able to take in an invoice, do some modifications, and give that invoice back out again as a new form. So I've created here an invoice modifier class, which, as you can see here, has a constructor which takes in our invoice, and that's fine. And then we have a few helper methods here to set the subtotal, to set the tax rate, or maybe there's some sophisticated logic that belongs in here within its single responsibility. And then we'll also ultimately return back an invoice that's kind of a copy, an updated version of that invoice, what have you. So this is absolutely fine. There's nothing wrong going on here. But now let's say somewhere along the line, the idea of an invoice changes. Maybe you have to be able to handle invoices from other countries or different representations of invoices or something more complex than what you originally thought it was. Well, because you don't want to have to reinvent the wheel every time you're going to do that, you're going to use a simple construct within the .NET framework or within C# or really any other sort of object-oriented type languages. You want to use some inheritance. So we've created a new class called complex invoice. Now a complex invoice is the same idea as a regular invoice, but there's a second layer of tax. Maybe there's a second tax rate for some other thing that's going on within that country or within that sort of institution or what have you. So the only thing that's really changing now from the base implementation, if we were to take a look at invoice, if we add another layer of tax, this is really the only thing that's changing. The calculation total calls into calculate tax, so we shouldn't have to modify this at all. So we're going to come in and take a look at our complex invoice, and we're going to create a new implementation, hence the new keyword, that's going to hide the base implementation here of calculate tax. And we're going to take into consideration this second tax rate. So we're going to take our subtotal the way we did in our previous invoice implementation, and then we're going to add in some additional logic here that's going to take into consideration that second tax rate. And then we'll just add them together and return them back, or whatever type of implementation or logic is necessary. No big deal here either. But the problem comes into play with this invoice modifier class, and then ultimately this set subtotal class. So what this basically means, or what the Liskov substitution principle means, is that if you were to take a base class, if you were to take, say, our invoice class, and you were to do some operation on this, that you should be able to pass in its place a subclass of that class, and the implementation shouldn't care. It shouldn't make any difference. So technically speaking, it doesn't. And I could pass in a complex invoice in here, and technically speaking, that would work. But when it comes to the setting of the subtotal, this is where the Liskov substitution principle begins to break down, because what is it supposed to do? What is this method supposed to do when it comes to this? Because now we have a second tax rate, which is going to ultimately affect the tax on the total invoice and the total. But in here, we're only dealing with invoice, so it doesn't really know about complex invoice. And you don't really want to introduce a lot of complicated logic to see, well, is this a complicated invoice or is it just a plain invoice? You shouldn't have to do that type of logic when it comes to the inheritance trees of particular classes. So that's where the Liskov substitution principle comes into play. If I'm going to create this tree of inheritance, then the classes or the operations or the methods that are using not only the base class but also the subclasses shouldn't care about them, and it shouldn't affect anything that's going on within either one of those types of classes, which in our case it ultimately does, because this invoice modifier doesn't know anything about this second tax rate and doesn't know how to change it, and we shouldn't have to do those extra checks in here. So there's really not a single bullet way to fix this type of a problem. It kind of just depends on the scenario. So in this case, what I might want to do is, instead of doing it this way, I should maybe create another type of modifier that would handle a complex invoice. So let's go ahead and see how we could maybe do that. So as you can see here, I've made a little bit of a modification to my application based on wanting to be able to pass the Liskov substitution principle. Like I said before, there's a couple different ways you can do this, and I've opted to go with the route of removing that inheritance, because ultimately I could keep that inheritance, but then I would have to introduce some more complicated logic in other places. So what I've decided to do is remove that inheritance and have this function as its own complete invoice or type of invoice, where I'm not actually inheriting anymore from that base class. So I have the same properties as I did before, but I've added in the second tax rate with the modified version of the calculate tax method. I've also introduced a complex invoice modifier, so it's going to have similar operations as it did previously. But in this case, I'm actually being able to only deal with the complex invoice, and then I know how to set not only its tax rate, but also its second tax rate, and have that function properly. So in this way now, these methods not only adhere to the Liskov substitution principle, because now I'm not concerned about being able to handle subclasses and base classes coming into these methods. I've completely separated those things out so that I don't have to worry about doing any additional checking of, is this particular object a type of invoice, or is this particular object a type of a complex invoice, and then basing logic on that, because that can become very complex later on should we introduce additional types of invoices. So in this way, we're able to keep that logic separated, because once again, if we were to do a bunch of checks in there to say, well, if it's this type of an invoice or if it's that type of an invoice, then we're starting to violate that open-closed principle that we talked about before, and then we would have to modify that implementation again. So in this case, we've decided to keep it as separate as possible. So now we have two different types of invoices that look kind of the same but do not have that inheritance. So one way to really kind of watch out for this violation of this particular principle is be very choosy of when you're deciding to use inheritance. It's not a bad thing to use inheritance. It's actually a very good thing, but depending on your implementation and depending on how you're using that inheritance, you might just need to be careful to make sure that if I can pass a base class of something into a particular method or a class, I should be able to pass in any of its subclasses as well. And that's definitely something we begin to overlook from time to time. So just something to keep in mind. So now that we have that basic concept down, let's move on to the next part of the solid design principles, the I, which stands for the interface segregation principle.